So we say cardiovascular systems. Cardio means heart. Vascular means blood vessels. Cardiovascular systems, including heart, blood vessels, and certainly including the blood circulation inside blood vessels. So that's mainly three parts in the cardiovascular system. Today we go to blood first. Next week we go to the heart and the blood vessels. So thus we say cardiovascular systems, including the heart, so that's the medical words for heart, and the blood vessels, that's the medical words for blood vessels, and certainly including the blood circulation inside blood vessels. So we say we're talking about blood first today. So blood is important to maintenance of homeostasis. Blood function mainly is transport function. What they can transport? Oxygen. That's the mainly important part. And also carbon dioxide. That's the waste production of our body, but we need to relieve it. And some nutrition, like after eating, some nutrition sending to all over the body by the blood. And we just finished endocrine systems. We're talking about hormone. Hormone transmission still by the blood. So hormone secretions then through the blood especially go to body cell, or maybe we use target cell. What means target cell? Kind of one-to-one kind of matching or action there. Like a special kind of hormone. They working go to special kind of tissues. For example, thyroid gland, they as a target cell or tissue is the thyroid hormone stimulation by the pituitary gland. So that kind of one-to-one, but the transmission by the blood. Otherwise, pituitary gland secretion in the head, how they can reach to thyroid gland there. And the blood also have functions regulating blood pH level. So normal blood pH level about 7, about 7. Not too high, not too low. Not too high, not too low. That's our internal environment balance there. And also regulating body temperature. We say normal body temperature about 36.5 to 37.3. And also, like they have some cells in the blood circulation and some protein as antibodies circulation in the blood. So that kind of cell and antibodies can protect it for itself against some illness. So that's the main function of the blood. So here there's some detail here. Here there's some detail here. So function of the blood. We say the first important function, transportation. Yeah. Transport oxygen. So that's from the lung to the cells all over the body. And the transport carbon dioxide. That's from the body cells to the lung. And then we relieve from the lung. And also transform the nutritions. The nutrition generally they will coming from our digestive systems through the stomach, mainly small intestine, absorptions, nutrition, then transform to the body cell. And the hormone we talked about already is coming from endocrine system's glands and then to all over the body cells. And also transport some heat. Where the heat coming from? The basically body heat coming from two sources. One is organs or form functions, they generate some heat. Like the stomach perform digestive function. They moving, the muscles, smooth muscles moving there, producing some heat. Another part are skeletal muscles. Skeletal muscles contractions, they generate some heat. Like some people feel cold, they choke. Yeah. When they choke, the muscles contraction there. When they muscle contraction, they generate some heat. And also like people go to gyms, do some physical exercises there, and then they feel hot, got a lot of sweat. So that's the heat coming from. And then through the blood circulation, sending all over the body. If too much heat, they will send into the superficial of the body, get some sweat, and relieve it. Otherwise, just the maintenance, normal body temperature. And the blood also transmission some waste productions. Carbon dioxide is just one of them. We also have some others waste products during our metabolism. We still need to relieve it, like from the urine. So how transport? By the blood. So that's basically transport functions. And also we talking about blood functions regulating. So regulating is kind of maintenance function. Maintenance homeostasis inside the body. And maintenance everything in the body fluid part. And also we say it regulating pH. So we say normal pH inside the body 7.35 to 7.45. Sometimes they say close to 7, yeah, close 7, but now a little bit higher than 7. Yeah, so that's the normally range. Too high or too low will cause the people sick or illness. So how to regulate it? Through the blood circulation. If too much, just relieve it. And also regulating body temperature, like we talked about before. Some heat generations. So basically from internally, and they can like too much heat sending to the outside. Yeah. So that's regulating there. And the protection functions. Protection functions, we still separate two parts. One part protected of a body injured. When body injured, basically people will be bleeding. So inside of blood, we have a lot of protein in there. It can be clots. And then, like somewhere is blood vessel is injured, then they go to there and stop bleeding there. Another part, protection functions. So we say we have some special cells and antibody can against some illness, especially caused by passengers like virus, like bacteria. So that's the function of the blood. Then we're talking about what the blood look like. Look like everybody know the color of the blood. The color of blood is red color. Red color. Let it be denser. Let it be denser or sticky. So we just compare with the water. And the temperature of blood, let it be higher than body superficial body temperature. So we say blood temperature is 38 degrees centigrade. And let it be alkaline pH. Thus we say normal pH range. And generally say blood is red color. But still let it be difference depending how much oxygen inside. When more oxygen inside, like in the artery, most artery, here we just say most artery, except the pulmonary artery. Thus, more oxygen inside is bright red color. Is low oxygen inside, that's basically is the vein. Still accepted pulmonary vein. So that's dark red color. So basically, if you see blood red, that's more oxygen kind of blood. And inside the blood, mainly is water. All the actual cells fluid, about 20% belong to blood. So that's how much of the blood percentage for outside cells fluid. Then we're talking about how much everybody have blood volume. 5 to 6 liters. That's basically for the male, adult male. 4 to 5, a little bit difference, not big difference. That's for the adult female. That's normal number here. So that's basically inside blood, and control like blood values. Still negative feedback system maintenance, like we talk about the pH here. We talk about how much in here. That's controlled by the negative feedback system. Then we're talking about what inside of blood. Yeah, what inside of blood. So generally say inside of blood, we can separate with 2 big parts. One big part, we call it blood plasma. That's mainly is the water part. Another part is some cells, that's the formed part. So the tube here, you can see the tube here, that's a tube. And we take some people's blood, go to a tube, and put this tube, go to a special kind of machine, spreading it. After spreading it, we can put a lot of tube here, and with high speed, spreading it, and then put the tube like sitting there after 24 hours, and then the blood can separate like this kind of form. Above part is mainly water part. We call it plasma. Lower part, because it's heavy, so that's go to lower part here. That's basically is the blood cells. So basically we can separate it here. So generally speaking, our blood separate with 2 parts. One is blood plasma. That's mainly is the liquid part of the blood. Another part is the formed part. That's mainly is the cells. And some cells part, like cells after broken, and some part in there. So that's mainly we're talking about blood. We say we separate with 2 parts. So inside of blood, we can separate with 2 parts first. One big part, blood plasma. That's basically 55%. Another part is the formed part, basically is the cells. That's 45%. Then we see what's detail inside. Let's talk about the blood plasma first. So basically we say if we remove the formed part, then we got the blood plasma part. So sometimes we just say plasma, still means blood plasma. So in the blood plasma, mainly part is the water. And certainly we also have some other things in there, including protein. That's the mainly thing. in the blood plasma. So we can see this picture here is pretty clear. So we say totally in the blood, 50% belong to blood plasma. So that's 55% coming from the blood. Another 45% belong to formed or cells part. Then just doing these 55% here, yeah, we are not calculate the cells part. We just calculate from plasma part. Doing these 55%. Mainly is the water. The second big part is the protein. You are not necessary to remember the number here, but you can just compare how different it is. And we still have some other things, just some tiny small part, 1.5% in there, including other things in there. So what's in there? So we need to separate from here to here. Some irons, some nutrients, some gas, some waste productions, some like hormones. So totally together, just 1.5 in the blood plasma part. And we say mainly part is the water. Yeah, mainly part is the water. And then we have 7% is the protein. We have different kind of protein. So mainly protein, albumin, that's in the blood circulation protein, 54%. Yeah, still mainly part. And then another second big protein is globin. So we have different kind of protein in the blood circulation. And we also have some other proteins, fibrinogen. So fibrinogen's functions mainly cause the blood clots. We're talking about it later. So that's basically in the blood plasma, we say we have mainly is the water. Second big part is the protein. And we have 3 different kind of protein. And certainly we have some others. Yeah, just a small amount in there, other protein. But mostly protein belong to these 3 categories here. And inside blood plasma, we have some other things like irons, like the nutrition, like the gas, like hormones, like waste product. So that's totally together form 55% blood plasma. So water part, we are not necessary to talk about the detail, but protein part, let's talk about some detail here. Because protein, they will have different functions. Yeah, different kind of protein. They will have different functions. So we say most big part protein in the blood, yeah, blood plasma protein. albumin. So this kind of protein is the smallest one. Yeah, these proteins size is smaller, but they have a big number, big amount, but the size, individual size is smaller, but they have big number there. It's producing by the liver, and it functions mainly is transport function. Means they carry other stuff and then transport from one part of body go to other part of body, like hormones. We say hormones relate to the blood circulation, but some hormones, they like a combination with protein together, then they travel in the blood circulation. It's not hormone itself travel in the blood circulation. And also they transport fatty acid. So fatty acid is the smallest fat. It's coming from our digestion, like a fat digestion. And finally they form the smaller part in it. So that's the first protein we talking about, albumin. The albumin. Remember, small in size, big in the number, and also the mainly functions is transport and it producing by the liver. So that's mainly we try to remember. And the second protein we say that's globins. Globins, it also possible producing by the liver and also producing by the cells. Basically, is B lymphatosis can producing globins. The function of the globins, it working as antibody. So against the passenger invading, like virus and bacteria. They also performing some transport functions, but they mainly transport for iron, for lipase. Yeah, lipase still belong to fat. And the fatty soluble kind of vitamins, like vitamin A, vitamin D. Some of the vitamin is fatty soluble kind of vitamin. Some of the vitamin, like vitamin C, vitamin B, is a water soluble vitamin. So it mainly transport fatty soluble vitamin. Then we're talking about another group of the protein. We say Physiology. So these proteins still producing by the liver. The function is form the blood clotting. So we say normally they only working for some blood vessels is damaged. And we possibly got a lot of bleeding from the injured area. Then they form the clots there, and then blocking the blood flowing from the blood vessel go to outside. So that's still the normal function of the protein. So that's basically we're talking about the blood plasma part. Yeah. Water part we are not necessary to discuss. And the others, yeah, other solid things like ions, nutrition, gas, we are not necessary to discuss here. We only discuss some detail. So basically, these three proteins in the blood plasma part. Then we go to the form part. Yeah, still go back here. We say blood separate with two big parts. One is plasma part, one is foam part. So basically in the plasma part, including the water, that's the mainly, including the protein, including some others. So we mainly discuss protein. There's three different kinds of protein we discuss. We are not necessary to discuss for water, not necessary to discuss other stuff. Then we discuss the formed part. Formed part, mainly we discuss cells. The part of cells we are still not necessary to discuss. So then we discuss the cells. So basically the cells in the blood circulation, we have three different kinds of cells. Red blood cell. Usually we simply say RBC. And the white blood cell, we just say WBC. And the platelets. So in our blood circulation, we have three different kinds of cells. Let's see the picture here. So that's basically here means in the blood circulation, we have 45% in the blood belong to cells or formed. So you can see different kind of cells in there. Then we separate here. Yeah, then we separate here. The first big group, yeah, you can compare the number here. You are not necessary to remember the number, but you can compare the number here. First big group is red blood cell. Then second group is the platelet. So you still compare the number there. So that's the unit. Yeah, that's the unit, the same unit. And then white blood cell, the smallest number there. But even it is smallest number, they still have different form. So red blood cell just one form. Platelets just one form. But white blood cell, they have 5 different forms. But the most mainly big form is neutrophils. So that's just the basic picture of the blood cells. The second big form is lymphatosis, like we just talked about. Like lymphatosis cells can producing some protein in the blood circulation, globin. That's this kind of blood cells. Then we have some others, just small amount in here. So here is the picture. We're still looking for the blood. Yeah. So we use microscope. Make it 400 times bigger. Then we can see the picture like this. Then we can see all these kind of shape in here. That's the red blood cell. And we have some cells looks a little bit bigger, and there are difference. That's white blood cell. Then you can see some smaller one. That's the platelet. And if nothing in there, look like empty. That's blood plasma. So that's basically we make it our blood 400 times bigger. Then we can see it. Then we make it, we make it 3,500 bigger. So that's basically by the electrical kind of microscope, we can make it much bigger. Much bigger. Then we see the blood cells like this. So that's the red blood cell. Pay attention to the shape. Pay attention to the shape. And that's the platelets. That's the white blood cell. Look like more beautiful here. Then we go to individually blood cells one by one. Let's go to red blood cells first. Red blood cell, 8 functions, mainly carry oxygen. This kind of oxygen is carried is by the protein inside of blood cells. So this protein we call it hemoglobin. So that's inside of red blood cell. We have a special kind of protein. So it looks like make it bigger and bigger and bigger. Yeah, we take some hemoglobin, go outside and make it bigger and bigger again. Then we see some picture like this. That's the hemoglobin. So when we're talking about the cells, we say we will have cover of the cell membrane. Then we have nucleus. But for maturity red blood cell, maturity red blood cell, it don't have nucleus and don't have other organelles. We say some tiny small organ inside the cell. That's we name it. Yeah. Organelles. So in this way, they can hold in lot of human globin. We can just shortly use HB as human globin. So that's the basically red blood cell. Then we see the function of red blood cell. Oxygen transport means carry oxygen mainly coming from the lung, go to the tissue cells. So that's the mainly thing. Yeah, mainly thing. Carry oxygen. And also, yeah, hemoglobin also carry carbon dioxide away. But it's not like oxygen. Oxygen is all carried by the hemoglobin. But carbon dioxide, that's part of them carried by the hemoglobin, means carried by red blood cell. So carbon dioxide totally no use, yeah, useless. That's the waste production coming from the metabolism. Then, like the radio say, red blood cell is not a life for whole life. Like everybody get red blood cell from their birth until they die, the same red blood cell. It's not true. It's not true. So they still have their lifetime. The lifetime for red blood cell, 120 days. So still remember where the red blood cell producing red bone marrows. So red blood cell producing in the red bone marrows. So red bone marrows basically in some space, we call it a spongy kind of bone, like a flat bone, like a head part of the long bone. So that's basically a red bone marrows located part. And in there, they producing red blood cell. And the red blood cell relief go to blood circulations after 120 days originally. And then they ending its life. So broken down in the spleen and the liver area. So that's basically the red blood cell and their life cycle. And the part of red blood cell, they still can recycling, still can reuse to build up new red blood cell. So that's the mainly we're talking about red blood cell and the functions. Just give you some basic idea, the number here, but you are not necessary to remember the number. Like how much normally red blood cell in the blood circulation for the female and the male, and how much hemoglobin in it. But generally speaking, if the number decreased basically both for red blood cell and hemoglobin. That's the illness we call anemia. So that's pretty common for a number like a low. It's not that common for number higher, like a number increase. So usually, like some situation can cause. One situation is relatively. What means relatively? We say inside blood circulations, we have percentage in there. 55% is the plasma. And then other part is the cells part. When we calculate, pay attention to the unit. We use like how liters and how many cells in there. That's truly we take whole blood out, and then we calculate how much in there. If some people suddenly losing more blood plasma, so that's truly changing the percentage here. So that's if we test, truly some people high number in there. So that kind of situation we say relative kind of higher, relative kind of higher. Another situation, it is higher in there, number in there. So basically that's kind of sick or illness. Like their bone marrows produce more red blood cell and then release to circulation. That's basically is kind of a sick condition. Yes, sick condition. Mostly more unmaturated kind of red blood cell release to the blood circulation. So if we calculate, it's increased. So that's two situations. One situation is red blood cell number decreased. One situation, red blood cell number increased. So red blood cell, not everybody the same. So attaching for red blood cell, some special protein in there. These kind of protein, they are different. So that's we call this kind of protein is antigen. We have different type. We have A type, we have B type. So if patient have A type kind of antigen, we just name it the blood pattern type A. If patient have type B kind of antigen, we just name their blood cells type B, or just blood type B. Yeah. Type A kind of blood, type B kind of blood. What are we talking about? We're talking about what kind of antigen in the red blood cell. And some people, they possibly have both antigen A and antigen B in their blood cell. So these kind of blood type, we name it type AB. Yeah, type AB. If they don't have any kind of antigen in their blood cells, we just name it type O, like 0. So that's the blood type coming from. So we name people's blood type depending what kind of antigen in their blood or on their blood. usually on the superficial of blood, red blood cell. So naturally, patient have antigen, they will have antibody. But the same antibody not happens in the same person. Otherwise, antibody will against antigen and cause the blood cells broken. So that means A type kind of blood people, they will have antigen B, antibody B, antibody B. They have antigen A, but they have antibody B. That's A type. And the B type of the antigen, their blood only have antibody A. So they are not against itself red blood cell, but they will against other people's not different type kind of red blood cell. And if patient have both antigen A and B, so basically no antibody in their blood circulation or blood plasma. And if patient don't have antigen, nothing in there, their blood circulation will have both anti-A and anti-B antibody. So that's basically when we're talking about blood type. We're talking about blood type. So when blood donate, we expected the same type kind of blood donate to the same time kind of person, not cause trouble. But for some kind of condition, we may not have exactly the same blood type. So what we can use? So basically, like we can use the type A or type B for type AB, and even type O for type AB kind of patient. We say type AB kind of patient is the whole receptors. They can receive any kind of type. Certainly, still not too big amount, because our blood transport still kind of plasma will be coming. So that's basically, and type A and type B, if we don't have the same type, we only can receive type O kind of donate blood, because their blood cells basically don't have antigen. If some people, their blood type is type O, they only can receive type O kind of blood. No type A or type B or type AB kind of blood they can receive, because either of them coming in their blood circulation, they have blood plasma, and the plasma have both anti-A and anti-B antibody there. They directly killed cells, make it broke. So that's not working this way. So that's about our blood and the blood type. So basically here, we're only talking about ABO blood type. Truly, we have RH blood type. Thus, only separate positive and negative. Most people is positive. Some people, they are negative. So when we do the blood transplant, we need to match both these two systems. We are not only match one system. We need to match these both two systems and match both blood type. Otherwise, they will cause the troubles. So that's basically about our blood type. Just try to understanding. Like our blood type by what kind of protein on the red blood cell, and like Y type AB can donate it for any blood type, and Y type O, they only can receive type O kind of blood. So that's for the red blood cell part. Then we move into white blood cell. White blood cell, we say we have 5 different types. Their lifetime is different. Some white blood cells, their lifetime is longer, like a few months or even years. Some kind of only living for a few days. So it's not like a red blood cell. Red blood cell living will have standard time, 120 days. And generally say the number increased white blood cell usually caused by inflammations or infections. So during that time, some kind of white blood cell may only living for a few hours, like they coming and then they perform function, then they die. So that's white blood cell, and that's the less number in the blood circulations normally, compared with red blood cell and platelets. So that's 5 different types of the white blood cell and what they look like and their size compared here. So we say we have 5 different kinds. Yeah, 5 different kinds. Then we're looking, the number here. Neutrophils, neutrophils, always the big number. And then lymphatosis. So these two mainly cover most part of white blood cell. Another 3, less than 1%. Less than 1%. Just small number in there. And certainly a little bit amount for immaturity white blood cell. It's not another category, just the immaturity in there. So that's some number in here. Just give you some idea. You are not necessary to remember all the number here. Mainly we try to remember its functions. So neutrophils, that's the big number in white blood cell. If its number getting higher, what's kind of situation? cause its number getting higher. Acute infection. So atrophy mainly function anti-inflammation, anti-infection. So if infection happens, they need coming more to anti-infections. And some other situations, big bleeding or injury, that kind of situation, kind of body reactions because losing blood, including white blood cell losing, then body producing more and make it number increase. And other special circulations, blood systems illness. It can cause the neutrophils number increase, and some kind of cancer can cause. So that's basically the situations cause white blood cells, especially neutrophil number increased. And the number decreased, low number. Low number, we say acute infection can cause the number increased. People got the infection for long term, maybe even cause the number decreased because they continually use the white blood cell neutrophils. And the blood systems illness can make the number increase. Also possible make the number decrease, depending different kind of illness, different kind of situations. And other things, like people go to X-ray or some toxins can kill the neutrophils, make the number decrease. And the people have immunity systems disorder can cause the neutrophil number decrease. So that's for neutrophils. Then we talk about lymphatosis. That's the second big number for white blood cell. If it increase number, still by the infections. If they increased, also possible for cancers. Generally speaking, yeah, what's the difference? The number decrease. Generally speaking, bacterial infection mainly cause the neutrophils number increase. And the virus infection mainly cause the lymphatosis number increase. So different pathogens, they cause the white blood cell reaction is different. And the number decreased. So X-rays still kill the blood cell, including the neutrophils, including the lymphatosis. And the immunity systems still cause the number decrease. And also especially use some hormone. That's hormone coming from endocrine system's cortex part of the hormone, like cortisol. So still cause the lymphatosis number decrease. So that's the first two white blood cell. The other three red blood cell, basically just small amount in there. Their number increased. They have some meaning there. Their number decreased. Basically no meaning. Yeah, no meaning. The number pretty small in there already. So basically the number decreased, no meaning. So monocytosis. So that's still can cause by some infections. Yeah, infections. Some special kind of infections can cause their number increase. And the blood systems illness can cause increase. And another one, basically, we're talking about hypersensitivity illness. We're talking about allergy. So when allergy reactions, these kind of white blood cell number will be increased. And also patient have parasites inside the body, the number will be increased. And the others still possible increase for the allergy reactions and also possible for the cancer. So that's 5 different kinds of white blood cell and their functions. So then we're talking about the immaturity kind of white blood cell. Immaturity kind of white blood cell, if increased, normally still pretty small amount in the blood circulation. So decreased, still no meaning. Increased, happens during acute infection. So still bone marrow producing lot of white blood cell, but because they use too much, they even release some immaturity white blood cell go to blood circulation. And the same meaning when people got big bleeding, then cause the number increased. And also that's blood system kind of illness. When it happens, still some immaturity kind of white blood cell can release to the blood circulation. So that's about our white blood cell part. Then we go to the platelets part. Platelets still producing in the red bone marrows. So it's less than red blood cell, more than white blood cell. Platelets function, stop bleeding when damaged blood vessels, and then they can form a platelet-like plaque and stop bleeding. That's the function of the platelets. So like the picture here, that's the normal circulation inside of the blood vessels. We have a lot of red blood cells in here. We have some white blood cells in here. The smallest one, small size here, just the platelets. Platelets still living short time, short time. Originally 5 to 9 days. And then they died and removed still in the spleen under the liver. Similar like red blood cell. And the normal number here, Then we say the number lower. What kind of situation causes the low numbers for platelets? So some disorder cause the producing less. And some reasons cause the cost more. And sometimes platelets, like they are not truly go to blood circulation, they go to other tissues. So that's some reason cause the number for platelets is low. What situation cause the number higher? So still abnormally producing still belong to blood systems disorder, and sometimes relatively increase. That's just short time, like is try to like losing more blood and then or losing some blood plasma, then the number increase is not a big deal. So that's basically about the platelets. Then we're talking about how the platelets plaque formed. So platelets plaque is basically stop blood loss. If we have injury or make a hole in the blood vessels, and then the platelets will be working. So that's some picture here, like from beginning, like the injury here, the injury here, blood vessels injury here, then platelets are touching there first. Yeah, lot of platelets will be coming and then attaching there. Then platelets, normally platelets circulation in the blood is inactive kind of form like this. When some injury happens, when some injuries happens here, and the platelets are touching go to local area, then they will change into active kind of form. So you can see even the shape is changing. And then they will touching each other. So that's the reaction in here. So then platelets working with some protein in the blood circulation together. We remember we have third kind of protein in the blood circulation, basically helping to stop bleeding. So that's some platelets, active kind of platelets. There's some protein fabric together fix local bleeding problems in there. So that's basically the plaque, the formed process. So picture here just coming from like an electrical microscope. If we make 900 times bigger, we can see like this. If we make even more bigger, 1,600 bigger, then we can see some fabric. The red part here is some blood cells, red blood cells in there, and some white blood cells in there also. So that's basically platelet and their forms process. Then we're talking about bone marrow transplant. So bone marrow transplant basically happens when people have some sick. Then the bone marrow not working. We know bone marrow is pretty important producing the blood cells. If some people have some illness or some abnormal bone marrow in there and couldn't producing the healthy blood cells, we need a bone marrow transplant. So that's basically we take some bone marrow from like a hip bone area, and then injection to other people's vein, and that will be follow the blood circulation. They still go to the patients like bone, bone, high flat bone or long bone head part. Then they will growth in there and producing more healthy blood. Pretty similar like blood transfusion. We still need matching the blood type. We still need matching the blood type. And we also need to use some medications control the receptors like immunity systems. Otherwise, they will be against donate some bone marrows. So that's like some picture here. That's the donator. Donator. So basically, we take the bone marrows from the hip bone area, and then the receptors, before receive the bone marrows, need to use some medication, drugs, to like decrease immune systems, and even sometimes we use radiation. So generally meaning decreased immune systems. Otherwise, they will be against the bone marrows coming from other people, even we still need much. And then injection the healthy bone marrows to the people's blood circulation. Then they will travel, go to all over the body, and finally go to the bone and go to producing new bone marrows and producing new cells in there. So that's about bone marrow transplant.